Hey guys, Hayden here again from Alarm Systems Store, and today I kind of wanted to go back to basics and talk about wiring. I've been getting a lot of questions about how to wire things in series and parallel, what the difference is, what point does it serve, things like that. So I kind of wanted to do a touch-up video on some of the stuff we covered early on our channel. Back then, Jason did a video on resistors. It's called All About Resistors. I'll put a link in the description. But in that video, he talks about the difference between in-series wiring and parallel wiring, etc. But there weren't many examples. A lot of it was diagrams that he was showing. So I want to kind of do a practical scenario demonstration where I actually show what it would look like. With wire and contacts and stuff like that. So what I have here today is just a couple of door contacts. I have a couple heat detectors that we're going to be playing with, and then a motion sensor, because this has what is called a Form C relay that has both normally open and normally closed positions, so you can use it either way. So first off, I want to talk about the door contacts. Door contacts are what are known as Form A type relay switches. Meaning that in its untouched state, as it is right now, inside that device is a reed switch with two metal prongs that sit like this. And Form A means that by default, when nothing is touching it, it will sit open like this. Whenever the switch is energized, or in this case magnetized, it closes that reed switch, which allows electricity to flow through the two contacts. So, practically showing what this is going to do, let's plug in our wires here. So now with the device hooked up, the flow of electricity through this circuit is very easy to actually explain. Up here on our system, I know it might be a little bit hard to see, I apologize, but basically I'm using the Z1 terminal for our yellow wire and the common associated with zone 1 as the green wire. What the system does to supervise circuits is it sends out a very small amount of current that flows through these wires, and it's going to flow out of one wire and back to the panel as long as it can get through the switch. So, in our normal state with our doors closed, as I said, our reed switch is going to be closed. So that means the electricity can flow out of our yellow, into the contact, across the reed switch, and out the green back to the panel. That's how it knows that you have a normally closed loop, because the circuit itself is closed, meaning electricity can flow constantly. Now, if we open the door, what happens is that reed switch breaks from each other, so the electricity goes through the yellow into the switch, and it stops because it has nowhere else to go. And that's what the system watches for to know whether or not there is an open or closed door. It's just watching for a circuit loop. If that circuit loop is broken or open, then it means that door is open. And if we wanted to, we could wire multiple devices in series. And the reason we do it in series is because of the way the system wants to watch that loop. So, in-series wiring would require a second door contact, and you're going to need at least one additional wire. This additional wire is essentially going to help create a loop out of these two contacts. So what we would do is, instead of attaching the green to the first one, we would attach our red here, and that way electricity can flow into the yellow, through this switch, out the red, into the next switch, and then if we attach the green over here, back to the panel. So if you can visualize it, what is happening is electricity is coming out of the yellow, hitting this first contact. If we have our magnet applied, the reed switch is closed here, meaning the electricity can flow into the red, into the second one. If we magnetize this reed switch, that one's closed as well, so it flows through the red and out the green back to the panel. So what we've done is just created a loop. We just have multiple points of contact, basically. So in an in-series wiring loop, if we remove either one of these magnets, it stops the flow of electricity. So right now, the electricity can get through the first contact, but it can't get through the second one. That tells the system the circuit is open. Same over here. If we remove this one, it can make it to the first switch, but it can't go anywhere else. So that is an open circuit. And that is why with normally closed devices, you wire them in series. Because what you are doing when you remove the magnet or unenergizing the device, you are breaking your loop so that your system knows, hey, one of those doors is open. And now, practical applications for this are pretty wide-ranging. For example, this is an easy one, but if you have multiple windows in your home, let's say you have 6 windows in your living room, if you make a home run back to your panel for every single one of those windows, the only benefit you are gaining is that you can name each window individually. Now, I can't think of 6 different names for 6 windows in my living room other than numbering them. So why do that when I can create a series loop and include all 6 of those contacts on one zone? And that way that zone's just called living room windows. So this can be used to condense your system down so that you don't have to worry about as many zones. It can be used to even chain multiple different types of devices if you wanted to. Wiring in series is easy as well because all you are doing is, like I said, creating a loop of power. And, for those of you that, may have had a pre-wired home and you're looking at this thinking, all of my sensors have 2 wires coming straight back to the panel. How am I going to make this work? How can I condense it down? What you can do is actually tie together zones at the panel. So to show that, what you would do is over here, we're going to have our red and yellow be one 2-wire connection that was meant for this door contact over here. Maybe if it would stop being ridiculous. Now, I'm going to grab this black wire over here, and it is going to be our second wire for this contact. So now we have 2 individual wires that are home run to the panel. So if I wanted to wire these in series, all I would have to do is, instead of wiring directly to the panel, take our 2 inner wires and connect those together. So in this scenario right here, as you can see, we have power flowing out of the yellow through the red into the black, from the black back to this contact, and then green back to the panel. So there's a lot more wire wasted in this scenario, but if you have home runs for each of your sensors and you're looking to kind of condense your system down so it's not so much to manage, this would be the way to do it. You can just, like I said, tie 2 wires together, and that allows you to create, if you look at it from like top down, it'll look like a W going back and forth from your house with the flow of electricity, but to the system, that's just one loop. That's just one complete circuit. So it doesn't care the path that the wires have to take. It can just send the electricity, and as long as there's the proper connections there, it will make it back to the panel and create that circuit. So one last thing on normally closed devices, resistor usage. So if you're looking to use resistors on a normally closed setup, you want to use the resistor in line. And what that means is the resistor will need to be acting as part of a wire, basically. So like in this case right here, I would pull my green wire out of here, attach the resistor in that terminal, and then splice the green wire onto the other end of the resistor. And that way, anytime this loop is closed, the system sees the 5.6K resistance that it wants to see. If I were to, let's say I wired this resistor in parallel on one of these circuits, that would not work, because what is going to happen, let's stick this in there real quick. Let's say that's how you stick your resistor. This is actually going to create a problem, because the resistor itself can conduct electricity, obviously. So with our loop here, what's happening is electricity flows out of here, goes through this switch, goes red, black, comes back to our second contact. Now, by default, without touching anything else, what the electricity is going to do is take the path of least resistance. So because that reed switch is closed, electricity is just going to flow right around the resistor. It doesn't care about the resistor because that's too hard. Electricity is very simple. It doesn't like to work hard if it doesn't have to. So it's just going to skip that resistor, take the reed switch circuit, and go back to the panel. So the system can't see resistance, so you're going to have a trouble condition basically saying you have a zone 1 fault. Now, the opposite of that, if we remove this magnet, we are basically creating a still closed loop. So if we look here, we have our yellow coming around, electricity's flowing, makes it through the first switch, goes into the second switch, and normally, if you're not using resistors, this would be open because the magnet isn't closed. The reed switch is sitting open right now. And the system, whenever it's looking at a normally closed device, wants to see an open circuit, which means no resistance period. It would show infinite technically, even though that means none, but anyway, back to this. What's going to happen here is instead of breaking this loop, the electricity is going to flow through the resistor and then back to the panel. So technically the system still sees a normally closed loop. It does see 5.6k ohms of resistance now, but it's not looking for resistance in an open condition. It's looking for resistance when everything is closed. So this is why resistors in parallel like this do not work. So if you're having trouble with your resistors, honestly, depending on what type of loop you have, it might be confusing, but just try swapping from a parallel resistor to an inline resistor, and that may just be the difference that your system needs. So most systems work like the DSC Neo, where it wants to see that resistance in its standby state, which standby state for an alarm system would be all of the devices closed, meaning all of your magnets are touching the contacts, all of your reed switches are closed, and you have that good flow of electricity. Now it wants to see that resistance at this point in time, so you would put a resistor in line, and that would allow it to always see resistance as long as the circuit is closed. Now, let's say go back to our 6 door contact scenario. If we were going to use a resistor, you're still only going to use one resistor, no matter how many contacts you have. But if you have multiple different devices, what you want to try and remember is you need to put the resistor at the furthest point in the circuit from the system. So in this particular scenario, that would actually be between the red and the black wires. So if we put our resistor here, that would be the furthest we can get from the panel. And that is because electricity, again, flowing out of here, comes back here, hits that, goes into the second contact and back. So if we stretch this out like this, you can see. So if we were to stretch this out, I know I'm messing up all my wires here, but if we were to stretch this out, you would be able to see that that is the furthest point from the panel. So that is how you would wire normally closed type contacts and how you would wire multiple devices if you were going to have multiple door or window contacts on a single zone. And now we'll move over to normally open type contacts. So for normally open devices, we are going to use a heat detector to kind of represent that. Now heat detectors are a bit special. As you can see there's a wax filling that is actually acting as the energizer for this switch. This is what would be considered a form B. So if we remove the wax and there was absolutely no outside influence on the circuit inside here, there would be a contact that's actually closed that allows electricity to flow through it. Now, this wax is used to hold that circuit open so that when the wax melts, it allows those contacts to touch, the electricity flows and it shows a closed circuit to the system, and that's what triggers it. So with a single normally open device, it's going to be wired exactly the same way as a normally closed one would. You'll have one wire in one terminal and one in the other. The difference is how the system monitors this circuit as compared to the last. What it wants to see right now is an open circuit, meaning infinite resistance. And this is why if you're ever using normally open type sensors, you have to use a resistor. Otherwise, the system doesn't know one way or the other if anything is connected at all. This is the only way a value can be placed on this circuit. So with DSC, we have our 5.6K resistors. And in normally open devices, we take the resistor and we place it in parallel here, like so. Now, what that allows the system to do is, by default, see that resistance. Because this is normally open in here, so electricity can only flow out the yellow, into this first terminal, through the resistor, into the second terminal, and then back to the panel. And what it watches for is whenever that circuit closes, again, electricity is going to take the path of least resistance, so it's going to flow through the yellow, straight through the contact, and back in. So we're going to see that infinite resistance again. And that is why with normally open detectors, we use in parallel resistors. And that is why if we chain multiple devices, we would wire them in parallel. Because again, the system doesn't want to see a closed circuit or infinite resistance, period. So if we had a second heat detector here, the way to wire this would be just like that for the first one. And then we're going to take our second wire, stick it in there like so. Maybe if I can, just go in your home, please. There we go. Out to the second device here. And then our red is going to do the same thing, but it's going to be on the green side. Like so. Sorry for the janky demonstration. It takes too long to actually wire this stuff in, so I'm just kind of winging it. But anyway, you get the idea. So as you can see here, our electricity now is going to flow out the yellow, into this terminal, out the black, because it can't make it across here, out the black to this terminal, and then it stops here. So if we had, because it's normally open with an alarm system, you're going to have to use a resistor. So the resistor goes on the last detector in a parallel loop. Now that allows the electricity to flow out the yellow, through the black, over to here, runs through the resistor, back through the red, back through the green, to the panel. So in standby, when the system thinks everything is okay, what it sees is just resistance on this loop. Now if either one of these wax rings melts, same scenario happens. Wax melts, closes that contact, electricity is going to flow through that easier path, and it's going to close that loop, showing infinite resistance. And that is what triggers your alarm system. And now, on to the last type of, real quick, just to make sure that, just to cover anything I might have missed, normally open is also called Form B. So like I said, in its untouched state, it is closed. Whenever it is energized, it is open. Now in this case, it is slightly confusing because for a heat sensor, this wax is acting as the energizer. That wax is holding the circuit open until the wax melts when it can close. So it's actually really simple design, but it kind of confuses the idea of what normally open and normally closed is, because with normally open, you would normally need some sort of energizing power, and that's what we're going to get into with the motion detector. So let me clean this up, and then I'll be right back with the motion. All right, I am back. This is our motion. It's just a regular LC100, nothing fancy, but it shows what we need to see. So let me get this in focus. All right, you can see the terminals there. We are going to ignore the T1 and T2, those are for a tamper, and we're also going to ignore the 12 volt positive and negative. Those are always going to be powered, so we don't need to talk about them. What we're looking at is these three right here in the middle, the NO/EOL, the C, and the NC. So this type of contact, which is known as a Form C type switch, allows you to decide whether or not you want to use a normally closed loop or a normally open loop. All it does is it's got a little switch in there that basically has these two connected at one time, and then whenever it's actuated, moves over and connects the other two. So the reason I'm bringing this up is because motions and any type of device like this that has a Form C setup is very easy to get confused if you're ever doing multiple devices. So if we were using the normally closed setup, you would have to wire these in series if you were going to have multiple motions on the same circuit. If you're using normally open, you would have to wire them in parallel. So it is very easy to get confused on that and just, stick the wire in the wrong terminal, and then you got a big problem and you have multiple sensors that you have to diagnose, and it turns into a big pain. So just be conscious of what you're doing while you're doing it if you're going to have multiple motions on the same zone. Now, I do have a question for those of you out there that may be more intelligent than I. Now, in this scenario, you can see the NO/EOL is where it recommends putting the end-of-line resistor. And I actually have a question for those of you out there that may be smarter than I. Why does it matter whether you use a normally open circuit as the EOL or a normally closed circuit? Is there any difference between the two? Because technically, I can set up a normally closed loop with this and put a resistor in series and still tell it to use a resistor. On the flip side of that, set it up for normally open, strap the resistor in parallel here, and it would work. So if you've made it to this point in the video and you have a decent answer for me, I would love to hear it down below, because I did some research and I cannot figure out why normally open is the preferred EOL type. Like on these, why do they recommend using the normally open setup for your EOL setups? And normally closed, being normally closed, that makes sense. It can only be one way. But with resistors, as long as the resistance is showing at the right time, you can make it work. So anyway, just food for thought. So if anybody knows, answer me down below. Let me know what the difference would be, if there's a difference, and why things are like that. So anyway, back to what I was saying. The reason I wanted to bring this up is because you can, with Form C type relays like this, you have multiple options for being able to wire multiple devices. So if you're using normally closed loops, you would create an in-series loop between all your motions if you were going to have multiple. And normally open type setup, if you're using resistors, you would use an in-parallel type chaining to allow you to connect multiple sensors in series. Now, 9 times out of 10, most people are not going to wire multiple motion detectors together, but if there's any of you out there that want to, just keep in mind the 2 previous methods that I showed you and apply them to whichever setup you choose on here. And another thing to note is not all motions come with a Form C relay. Some of them are just normally open, period. And in those cases, it makes sense why you have to use the resistor the way you use it. But on a Form C, I don't see why it makes a difference. So I just wanted to kind of touch on this before I ended the video. But basically that is, wiring for an alarm system. And now, if you guys want more info related to resistor specific knowledge, please check out Jason's video down below. He did a really good job on it. There's a lot of good info there, so check it out, see what you guys think. In this video, I hope I gave some decent practical explanations for wiring in series and wiring in parallel. If I did not, however, please feel free to ask any remaining questions you have. If anything I said confused you, let me know. I want to make sure these videos are as clear as possible, and that way anybody, even if you're starting from ground zero, you can build your way up into, an alarm tech. I mean, the alarm systems are not hard overall, in my opinion, but I also came into this business with a decent knowledge of programming on computers as well as electricity just in general. A lot of people aren't going to have that knowledge. So if there's anything that I didn't cover clearly enough in this video, by all means let me know so I can fix it. If I did a good job, let me know that as well. I always like to get compliments. They make me feel good. So tell me what you think down below. Leave us a comment. Like and subscribe if you're enjoying the content. And we will continue to try and put out more like this. So again, that resistor video is down in the description, so check that out there. And otherwise, I will catch you guys on the next one.